Okay, today we're talking about the law of conservation of mass. You learned about it in your warm-up in that video a little bit. So the law of conservation of mass basically says matter cannot be created or destroyed. So things don't just magically appear out of thin air, they don't just magically disappear. Things change form, they change the way that they look, but matter isn't created or destroyed. So think of like baking a cake. You get all your ingredients. You could weigh all your ingredients. How many grams of flour? How many grams of butter? You could weigh everything, but then you mix it all together, you put it in the oven, you bake a cake. It chemically reacts, so it's going to look different when it comes out. It better look different when it comes out or you did something wrong. When your cake comes out of the oven, matter wasn't created or destroyed, it just changed forms. So then if you take the mass of your cake at the end, it should be equal to the mass of all of your ingredients added together. That's basically what the law of conservation of mass states. So let's look at what it looks like in a chemical equation. All right, so on the left side of your notes, we start with a chemical equation. This right here, this whole thing is a chemical equation. Think of like a math equation. You have plus signs. Instead of an equal sign, we have an arrow, but something plus something equals something. It's kind of like a math equation, but sciencey. So the left side of the equation is called the reactants. Reactants. These are the things that react. So if we're baking a cake, this would be what we put into our cake. So the flour, the butter, the sugar, the egg. We would have a lot of reactants if we were baking a cake. And then in science, we have a fancy name for this arrow right here. It's called yield. It's just the name, it's called yield. It means equals or creates. And then the right side of the equation is called the products. I like to think of it like as your final product. So the cake that you take out of the oven, it's baked, that's your final product. So left side is like the ingredients. The right side is the new product or what you make. Reactants yield products. So a chemical equation is written like this. It has elements and compounds. So we recognize hydrogen, oxygen, and sometimes they will also include the masses on the chemical equation, which is what we have below. So in this chemical equation, there was 10 grams of H2 and 4 grams of oxygen, yields 14 grams of the product. That's how you read an equation. So let's scroll down a little bit. All right, so the law of conservation of mass applies to a chemical equation because the law says that the number of atoms, and I'm gonna skip this part for a second. The number of atoms on the reactant side must be equal to the number of atoms on the product side. So I just want to talk about atoms for a second. We know how to count atoms, we just did it. So let's look at the reactant side. We have CaCO3. So I'm gonna make a real quick, make a little EA chart, just so that we can see it. Our elements are Ca, C, and O. We have 1 atom of Ca, 1 atom of C, 3 atoms of oxygen. Let's look at the other side of the equation, at the product side. Let me make a little EA chart for the product side. So we have Ca, O, C, and O again. Ca, O, C, and I'm not going to write O twice. I'm just going to count it twice. So I have 1 atom of Ca, and right here I have 1 atom of oxygen plus 2 atoms of oxygen, gives me 3 total, and I have 1 atom of carbon. So remember, the law of conservation of mass says what you start with, so your reactants must equal your products. So we started with 1 atom of calcium, we ended with 1 atom of calcium. We started with 1 atom of carbon, we ended with 1 atom of carbon. Started with 3 atoms of oxygen, ended with 3 atoms of oxygen. So we can count the atoms, we can see that they're equal on both sides. Let's look at what the rest of this said. It said that the mass must be equal. The mass of the reactants must be equal to the mass of the products. All right, so in this one, we don't know the mass of the reactants, but I bet we can figure it out because it has to be equal to the products. So we have 23 grams here and 16 grams here. Normally this plus sign wouldn't be written for you, you just drop it down. And instead of putting an arrow, I like to put an equal sign. So if I was to rewrite this into an equation that looks like something you would see in math, we would have blank, or you can put an X there because I'll use X's in math, equals 23 plus 16. Can you solve blank equals 23 plus 16? Yeah, of course you can. You add 23 to 16 and you would get 39 grams. So we would replace this question mark with a 39. All right, let's look at this one down here. So this one says C plus, or carbon plus hydrogen equals this compound right here where we have carbon and hydrogen. We could count the atoms. We would find out that they're the same on each side of the equation, but let's look at the mass. We have 6 grams plus, because you dropped the plus sign. We don't know, it's missing. And I'm gonna change this to an equals, 19 grams. So let me rewrite that so it looks a little bit better for us. 6 plus, I don't know, equals 19. Okay, so what would you do in math class? Pretend this blank was an X. You would want to get X alone. So you would subtract 6 from each side and you would be left with blank equals, what's 19 minus 6? You can always use a calculator, 13. So 13 goes in the blank. So you want to check your answer. So if we put 13 in this blank, we want to make sure it's right. What's 6 plus 13? It's 19. So it's correct. So you're just making sure that the reactants equals the product in every equation because that's what the law of conservation of mass says. Matter can't be created or destroyed. So what you start with must equal what you end with.